All right, so today we're talking about another central tendency thing called range. Let's just go over an example first. So range, if I talk about range just in general, range usually means how far you can go. Okay, so for example, if someone's shooting a bow, the range is how far they can actually shoot it. So like 100 meters or 150 meters or whatever, some amount of distance. When we're dealing with numbers, it's very similar. It's the distance between the start and the end. So if we have like a big list of numbers like this, we're trying to find how far is it from the beginning to the end. Now, you have to be careful because the end isn't this number. The end is if we order the numbers from smallest to biggest. So the smallest number in this list would be 30, and the biggest list would be 90. So we're trying to find out how much is in between these two. Okay? So if I take 30 and 90, a lot of you would be able to do just quickly in your head, you know that the distance between them is 60, but we need to be able to have like a method so we can do that. So what you do is you actually subtract them from each other. So you need to do the big number minus the small number, and that gives you the distance. If you did it backwards, actually let's just do that. So it would be 90 minus 30 gives you 60, which means that the range is 60. If you did it backwards and you did 30 minus 90, you would end up getting a negative number, which is negative 60. So that's actually okay as long as you recognize, well, it can't be negative, so I'll just make it positive. Because it's like if you're measuring distance, right? If you go backwards, the distance is still positive. You can't have a negative distance. Some physicists will argue, but that's okay. So take the big minus the small, that gives you range. And that's what it says here. Now we want to know why this number is important, because it's really easy to find, probably easier than the other ones we've done, but we need to know why it matters. So let's take this first example, okay? Let's say I had a class, and the class average was 75. If I notice the class average is 75, I'm probably thinking, man, my kids are doing pretty well. They must understand what's going on. But the problem is, the reason we have all these central tendency things like median, mode, range, all this stuff we're learning, right? These help us get information about an average and tell if it is a good representation of the data or if there's maybe some information that we're overlooking. So in this case, the range was 50. And if I zoom out, you can actually see the numbers. These were the kids in the class, like this is made up. These are the kids in the class and all their marks. If you look at these marks, thinking average 75 might not represent this class. Because sure, if you added them all up and divided, you would find the average is 75. But the problem is, you have 3 kids who are getting 50, 3 kids who are getting 100, 1 kid getting 75. I don't know if this number represents the class very well. Okay? And the way we can tell is because this range was big, 50 is pretty big and when you're talking about 100%, there's a big gap between the top and the bottom. So when you have a big range, that gives you a clue that maybe the numbers you're looking at aren't very well represented by the average. Whereas instead, I look at this class. The average was still 75, but the range was only 10 because the smallest number was 68, the biggest number was 78, so there's a gap of 10. These kids' marks are all pretty close to 75. This 75 is a pretty accurate representation of this class. So the general rule of thumb is if you have a big range, like this first one, it's not as reliable data. Okay, the average isn't great. Whereas if you have a small range, like this example over here, the average is a little bit more reliable. It has more of a pattern to it. I want to do a third example where it's not perfect. Okay, so this average was 75 and the range was 50, which we said in the last example is pretty bad. But when I look at the class, almost all the kids got 75, except for these 2. So this is a situation where just because the range is bad, it's a big number, doesn't necessarily mean that we can ignore the other stuff. And this is a situation where in particular we would do trimmed mean and it would change it. But we're not actually going to, we're going to talk about that next class. So this is the main lesson. Don't always trust the average. You try and look at the other information like median, mode, range to try and figure out, is the number I'm looking at accurate and representative of the data? And that's it. Put the numbers in order, biggest, smallest, and subtract them. So like with this one really quick, 50 and 100 were the smallest and biggest. 100 minus 50, 50. That's your range. That's it.